Howdy folks, welcome back to another Out of Spec Renew video, and today we're working on one of my specialties, a Toyota RAV4 EV. For those that don't know, I used to work down at QC Charge in Southern California, and this car was pretty much our bread and butter. This was a car that we really specialized in, and I've personally worked on many hundreds of these cars. And that's saying something because there were only a little over 2,500 of them ever built. But basically, it's a third-generation Toyota RAV4 body with a powertrain very similar to an early Tesla Model S. So it has a large drive unit up front-wheel drive, that's flipped around backwards. Battery is built by Tesla, uses actually the same cells that the original Roadster did, but the way the modules and everything are built are pretty similar to the Model S. And then almost all the other high-voltage components that make up the car are shared with the Model S. The onboard charger, the DC to DC converter, the battery coolant heater, all that kind of stuff. There's a few things on it that are a little bit unique, like the cabin heater and one of the pumps and maybe a couple of other small little things. But for lack of a better term, it's almost like basically a Model S in a RAV4 body. But anyways, what we've got here is a couple things that we're going to take care of on this car. The first one is that the 12-volt battery is not being charged by the DC to DC converter. I already kind of did the diagnostic stuff on this, but I'll kind of give you guys an overview of what exactly is going on. And I've got a DC to DC converter that we're going to throw in this thing. And then we're also, while we're here, we're going to do a rotor coolant delete on this drive unit, which, of course, being a Tesla large drive unit, they're very prone to coolant intrusion issues. So it's a good idea to address that before it can cause a major failure, especially for the cars like this one that have the unique reverse rotation large drive unit. Parts for these are getting harder and harder to find. So anyway, first things first, let's go ahead and pull the cover off of the DC to DC converter here, and I'll show you guys what we're looking at. Kind of show you guys what we've got going on here. I've got my multimeter out. Hopefully you guys can actually see that. And the car's off right now, so we should just have resting voltage on the 12-volt battery. I did just have it on the charger because it was getting pretty low. But there you go, we're sitting at about 12.5 volts. And now I'll go ahead and start the car, and you'll see that we don't actually have output from the DC to DC converter. So the car's now on, and you can see we're actually, now that we have a load on it, the voltage is dropping fairly quickly on our 12-volt battery. The DC to DC converter actually lives under this cover right here. Looks like a Toyota dealer or somebody swapped these screws out because they're not the same as what it would have had originally. I think these folks bought this car not too long ago. Go ahead and set this aside. And this right here is the DC to DC converter. So right behind this cover is our positive terminals for the 12-volt battery. So we've got our positive side stuff there, and then our ground actually kind of connects behind here. You probably can't see it very well. And this also acts as a little bit of a junction box for a bunch of other high voltage systems. So we've got our this is the cabin coolant heater. And then we have our battery coolant heater, which kind of lives back down there underneath. And the last one here is for the AC compressor, which lives right over there. So anyways, in order to pull this thing out, we'll have to disconnect the high voltage system and block off the coolant line so that hopefully we don't lose too much coolant. And then we should be able to swap this thing out pretty easily. All right, so first things first, to disconnect the high voltage system is we want to disconnect our 12-volt battery. And then we'll go ahead and disconnect the high voltage disconnect, which on this car is under the passenger seat. So in order to get this out, there's a tab here that we're going to press. This lever pulls up, and then we press the tab again, and push the lever all the way vertical, and then the disconnect just pulls right off of there. All right, it's time to start disconnecting everything on the DC to DC here so that we can swap it out. So first things first, I'm going to disconnect all of our negative cables. Or sorry, I think I said negative cables. I meant positive cables. And it looks like this may have even been swapped once before, because I can tell that some of these clips have been pried out previously. So that one's off. We'll unplug our data connector here. All right, now I'm going to go ahead and disconnect all of these high voltage connectors. So they just have this red tab that pulls out on each one. Like so. And then I should be able to just grab them and unplug. And then they're all clipped on here. So I'll try and unclip each of these. Okay. Got another clip here on the side. And now what I'm going to do is I'm actually going to disconnect the cabin heater here, as well as its pump, which has a couple bolts down here, and another connector. Looks like we've had some rodents chew on some of the plastic sheathing on some of the cabling here, but no major damage, it looks like. Gotta unclip this coolant hose from the pump bracket. Oh, and I got one more bracket here to remove for a coolant line. And now what I can do is I can actually take this whole coolant heater assembly with all the hoses still attached and move it out of the way. So what I can basically do is take this whole thing and flop it over to the side. Although, it's going to be easier if I remove the 12-volt battery. So, might as well go ahead and do that real quick. Dang, it's been a while since I've worked on one of these. I keep forgetting all of the little nuances that make it slightly easier to do different things. Actually, whoa, nearly lost you guys there. Disconnect the positive terminal from here because these two cables kind of separate apart. There we go. We've got that right there. And actually the easiest way to deal with this is to leave the nut attached. Then we can just unhook the J-hook out of there, put it up out of the way. And then this battery bracket has another nut that's kind of hidden underneath of this plastic panel. So I'm going to unclip a couple of clips that hold the plastic panel down so that I can get a wrench underneath and remove this bolt. Alrighty. There's that. Now I can get our battery out of the way. And now we can go ahead and just stick the coolant heater and everything there off to the side. Now it's out of our way. We've got plenty of clearance here. I need a 17mm wrench. This is for the ground on the DC to DC converter. We've got another harness clip there. Another harness clip here, which I think I'm just going to kind of unclip and push that out of the way. I'm going to go ahead and disconnect our high voltage input, which is right behind this cover. whoever last did this didn't put the gasket on the cover here. So I think our replacement one does have an intact gasket on it. So that's good. But yeah, this definitely appears to have been replaced before, looking at all the evidence. I wonder when it was replaced. Oh, so it's a refurbished DC to DC converter. And based on the serial number, which is kind of interesting. The way that Tesla does serial numbers is kind of weird. For battery packs, they usually keep the same serial number from when the pack was originally produced. I think that may have changed in the last handful of years. And then for other part, well, and for drive units too. But in the case of this, it actually says T21I. So I would be A, B, C, D, E, F, G, H, I. So that's the 9th month of 2021. So that would make it a September 2021 remanufactured DC to DC. So it's really not that old. Interesting. Well, we'll go ahead and pull these cables out. Now, the funny thing on the RAV4 is that when they have a failure with the DC to DC converter like this, they don't actually throw any alerts for the DC to DC. They just, they'll continue to drive until the 12 volt gets so low that some of the electronic modules in the car start to freak out, and it'll throw other unrelated alerts. Just like you'd get if you tried to start an EV with a low 12 volt battery. They just glitch out and throw all sorts of random messages. And that's pretty much what happens on these too. Except it won't throw any alerts to tell you that the DC to DC isn't actually working, unlike a Model S. So right now I'm just clamping off the coolant lines so we don't have to clean up a giant mess of coolant. It'll spill some out of the converter itself, for sure. But hopefully we won't lose too much, and it should be pretty easy to purge the system when we're all done. So our coolant lines are clamped off there. I think what I'm going to do is I'm going to wait until we actually remove the DC to DC converter to try and take these off to minimize our mess as much as possible. But I will try and at least move that clamp out of the way. The one down here is kind of hard to move out of the way because there's this plastic sheath on the hose that's actually kind of in our way. But I'll try and move it down out of the way as much as I can. I think that'll work. And then all the fasteners that hold the DC to DC converter on, so it's on this bracket piece, which has a bunch of other stuff attached to it, but there's 4 fasteners on the back side that attach it, and you can kind of see where they are. So there's a nut here, there's a stud with a nut, there's a bolt right here, there's another bolt down here, and then there's another stud with a nut down here on the bottom corner. So I probably can't show that on camera super easy, but I will attempt to. I probably won't actually be able to show undoing them. Here on the back side you can see there our bolt right here. We've got our nut back there, and then we have 2 more on the bottom that are basically impossible to see, but they're not too hard to get to. Yeah. So anyway, I'm going to go ahead and get that stuff unbolted, and then we'll be able to swap this out with our replacement, which is actually right over here. So this is our replacement DC to DC converter. And this is actually just the DC to DC converter out of a Tesla Model S. It's completely 100% interchangeable with the one in the RAV4. So I'll go ahead and get that one unbolted, and then we'll stick this one in its place. All right, so we're completely unbolted here. The DC to DC converter is completely disconnected. The only thing left holding it on is our coolant hoses here, which we should be able to get off without too much difficulty. At least that's the idea. There we go. So we've got a little bit of leakage going on there, but not too terrible. I'll tuck this one up out of the way there. I forgot about one very important thing that is hanging us up here, and that is our connection for the positive terminals. Is that a 12? It's a 13. So let me grab a 13 and we'll go ahead and get that off of there too. There we go. That was kind of an important one to have overlooked, but our DC to DC converter is now completely removed, more or less. I just gotta squeeze it out of here. I think it might be easiest to get it out from this side. Alrighty, now we can take our replacement and just slide it right back in the same way our other one came out. And there it is. All right, the DC to DC converter is now firmly affixed. Go ahead and get some of our connections back on here. So we've got our 12 volt positive, sort of bus bar situation here. Okay, we'll get our high voltage plus and minus in here. And actually, before I insert those, I think I'm going to put just a little bit of grease on those O-rings. It'll help make sure it stays properly sealed. This is just a little bit of sort of silicone grease. It's kind of designed to use on O-rings and rubber stuff for lubrication. Okay. Go ahead and get our fasteners back on for those. Sweet. All right. Those are in. And our replacement DC to DC converter did come with the cover. And this one does indeed actually have the rubber seal on it, which the old one did not. I wonder if that could have been a contributing factor. I mean, it didn't look like there was any corrosion or anything in here, but yeah, not having the seal on it is definitely no good. Not the first time I've encountered that, by the way, on DC to DCs that have been replaced by Toyota dealerships. All right, we'll get our coolant hoses back on. So that one's pretty much there. Try and get the clamp back into place. Boom. And now our upper one. We'll also get that clamp back into place. I can remove our line clamps. It's kind of funny, the way that the RAV4 works with the cooling system, as you can see, is there are actually 3 different coolant reservoirs. So this one is for the battery system, which also cools the DC to DC converter. And then the one over here on this side is the traction cooling system. So that cools the drive unit and the onboard charger. And then there's this other reservoir back here with pink coolant in it. And that's actually just for the cabin heat. So that's actually regular, like Toyota pink coolant that it runs through just a standard heater core. Same as on the internal combustion RAV4. And it just has that heater that we moved out of the way to heat up the coolant. A lot of earlier kind of compliance EVs used systems like that, where they basically heated up coolant utilizing sort of an original style system. So let's see, that goes right there. We'll get these two positives there and our ground over here. Alrighty. That's our AC compressor. We've actually got another clip down here where that's supposed to go into that the zip tie has been cut off, it looks like. But it's actually pretty well supported. I might see if I can stick a new zip tie through there though and reattach that the way it's supposed to be. It's kind of supposed to be a clip with an integrated zip tie, but I think I can just stick another one straight through it. There we go. Now it's properly reattached. And then one of these had rodents chewing on it. I think it might have been the cabin heater. So we'll go ahead and get this back into place, which I kind of went a little bit out of order here because that's supposed to go there. That goes there, and then that plugs in, and this plugs in. Now we can get our cabin heater back into position. Yeah, so that's the one that got chewed on. You can see the critters chewed through the plastic casing. They didn't chew on any of the insulation though, so that's good. I might just stick a little bit of orange tape over that. We'll get this little harness, which is the control side for the cabin heater. Clip its connector back onto this tab and bend it down. Alrighty. We'll get our 12-volt battery back up here. And then before I connect that, I'm going to go ahead and put our high voltage disconnect in. We'll reconnect our 12-volt battery and start it up and make sure our DC to DC is working. Alright, the disconnect is in. I'm not going to bother bolting this down just yet. I'm just going to get it loosely into place. Get our terminal on here. All right, let's start it up and see if we've got power. All right, car's on. Moment of truth. Look at that. Well, of course, you can't see. Boom, we're operating at 14.6 volts. So our DC to DC is working perfectly. And that's that part of the repair basically done. All I got to do is just put the plastic cover back on here and bolt the 12-volt battery back in. Now the other thing that we want to address is we want to future-proof this drive unit against future coolant intrusion. So we're going to put a rotor coolant delete manifold on it. Alrighty, so we've got the RAV4 up on the lift here. We're going to go ahead and install that rotor coolant delete manifold. Of all the cars that use the Tesla large drive unit, which the vast majority of which are, of course, the Tesla Model S and Tesla Model X, depending on which variation they are, only rear-wheel drive and performance versions. But the Toyota RAV4 EV here and the Mercedes B-Class electric drive, or B250E, also use the large drive unit in a reverse rotation configuration. Of all the cars that use the large drive unit, The RAV4 is the easiest one by far to install the rotor coolant delete manifold on. All we got to do is pull off this tire. There's a plastic cover in the wheel well there, and just a kind of a piece of bracketry underneath that we've got to remove with a couple of 17 millimeters, and then we can basically just unbolt the manifold and swap it out. So I'm going to go ahead and pull this wheel off. I'll pull the bottom cover and the side panel, and then we can kind of get to the rest of the disassembly process. All right, so we'll go ahead and get the bottom cover off here. It's got a handful of clips and some screws. All right, let's take a peek underneath. I'll grab my light here and stick it on. So is this drive unit original? It looks awfully clean. No VIN plate here, so if it was original, vast majority of them would have a VIN plate. So what's it say? T18A, so January of 2018 drive unit. And it appears it was new, not a reman. At least it doesn't have a reman code on it. And somebody worked on it named Hoser, I guess. Hoser 2022. Don't know what that's supposed to mean. But anyway, our manifold that we're going to replace is this right here. So I'm going to remove this bracket, which just has 4 more bolts in it. And we'll remove this bolt on the top of the manifold where the crossover tube attachment back here disconnect well. And then we can kind of bend the tube upward just ever so slightly so it's out of the way. Remove our speed sensor. And then there's just 6 bolts that hold the manifold itself in. And of course, a coolant line here too. So the first step in the process here is going to be to remove our cross member here. And now we've got easy access to our coolant manifold here. I'm going to grab some coolant line clamps. I'm going to clamp this one off, and I'll clamp off the line on the other side. It's just right on the other side of the differential there. That way we can minimize our coolant loss and hopefully not have to bleed too much air out of the system. There we go, there's that fastener removed. And then there's another one that's a bracket, kind of just back here behind this motor mount. It's kind of difficult to really see, but it is accessible most easily with just a ratcheting wrench. Actually, I kind of can see it from my angle here, so I'll show it to you guys. That bolt that we're looking at is right back there. Maybe. Anyway, it's that black bracket on that coolant line is what I'm removing. So there we go. Finally removed that one. Now I should be able to kind of just push this tube up slightly and just bend it a little bit out of the way. Just like that. I'll go ahead and unplug the speed sensor. All right, now I can pop the manifold off of here. It's gonna gush a bunch of coolant out of the bottom there when I break it loose. So got our bucket at the ready here. That wasn't too bad. Just rotate that a little bit. And there we go, our manifold slides right out. So that's our old rotor coolant manifold. We'll save the O-ring because we're going to reuse that. And I'll go ahead and get our replacement manifold for this thing. Alrighty, so we're about ready to install our rotor coolant delete manifold. I've got our sealing surface here all cleaned up. There's no gasket maker left on there. I probably need to clean up a little bit more coolant in the tube there, but I do want to clean out these holes where those bolts go in, because there was quite a bit of gasket maker in there. Obviously this bit is smaller than what the threads are in there because we don't want to damage the threads. But I think we're cleaned out enough there. Looks like this one might need a little bit of cleaning too. I think we're good. To clean out the coolant in the inside of that tube there, I'm actually going to take a really long pair of pliers, if I can find them. Here they are. I'm basically just going to take one of my blue towels on this really long pair of pliers. I might even rip it in half so it's not so big. And I'm basically just going to fold it, grab a hold of it with the pliers and wrap it around. And this is slim enough that it'll fit right in there all the way to the back. And I can make sure to wipe it out so it's nice and dry. I'll take the other half of my towel that's a little bit more dry and just finish it off. Nice. And I'll take one more fresh towel and make sure we're perfectly clean on our sealing surface here. Down here we're just going to have an O-ring. Sometimes it's beneficial to put some sealant on here too on the lower face, but it's not always necessary. Like I said, it has an O-ring. This one from the factory didn't have any sealant around it. Usually only the really early ones do. Anyway, we'll go ahead and pop our O-ring back in here. And then for the delete manifold, this customer is just getting the basic delete manifold, which is just an OE manifold with the seal removed, the tube broken off, and then this cap pressed into it. I do carry the billet manifolds from QC Charge as well, as sort of an upgraded option. Basically just makes it a bit easier to identify that the car has a rotor coolant delete, so for resale value, it's kind of a nice thing to have. But anyway, we're going to go ahead and get some sealant applied on the upper portion here. Went a little bit thin through that section, so we'll give it just a little more. In case you were wondering, this is Permatex Right Stuff 1 minute return to service. Works great on this kind of stuff. It's actually officially the spec that Tesla uses for a lot of components, including the drive unit stuff, is this particular Permatex material. All right, so we've got that all siliconed on. And now we'll take our delete manifold and just pop that right into place. Go ahead and get our bolts started. And I usually like to tighten these by hand just to make sure they're not going to strip out, because that old dried up gasket maker can sometimes get in the bottom of the holes, and it basically limits the travel that the bolt can go, and then it'll just end up stripping the threads out of the aluminum. Done that more than once. So now I usually err on the side of caution. Alrighty, that's all tightened down. Now I can just go ahead and get the coolant tube back into place, reattach all of those bolts, and put everything else all the rest of the way back together. Alrighty, well that's going to be a wrap on this one, folks. Of course, we got our old DC to DC swapped out with a new one, or, well, really a used one from a Model S. But that got this car back on the road again. And of course, with the rotor coolant delete on it, the motor should be future-proofed against hopefully any catastrophic failures in the future. The customer actually originally brought this car to the Toyota dealer, and they had no idea what was wrong with it. They put a 12-volt battery in it and then said, it's fine, there's nothing wrong with it. They cleared out all the codes and stuff. Apparently they flew in a special Toyota technician, which is kind of the norm thing for Toyota to do on these cars because most of the dealers don't have any trained techs for them. So they flew in a special EV technician, and yeah, they couldn't figure out what was wrong with it either. And that seems to be pretty par for the course, unfortunately, on the RAV4. Most Toyota dealers just don't really know anything about them. There's a handful of pretty good dealers in California that deal with lots of them, because that's where all these cars were originally sold. But anywhere else, they might as well be an unsupported car. And of course, anything from the Toyota dealer costs a fortune on these. Whereas, you know, using second-hand Model S parts can be pretty inexpensive. So, anyways, yeah, this customer's back on the road. They should be good to go. And if you guys like seeing this kind of content, stay tuned for more repairs like this in the future. Thanks for watching.